Hmm. Okay, we're going to go ahead and continue where we left off with liquid penetrant inspection last time. I have a couple announcements at the end of class, so we'll wrap up early enough to go through those. I've got some things I need to hand out, and we'll talk that over as well. But I wanted to start with this so that you don't spend the whole class thinking about the other stuff that we're going to go over. So we were talking about penetrance, and we kind of talked through physical properties. Let me get my clicker working. There we go. So we had gotten through physical properties, things like wetting, the ability for capillary action to take place, and how that plays into what makes an acceptable penetrant. So today now we're going to look at different I'm going to say types, methods, forms, but essentially the process of performing liquid penetrant inspection and how we classify the different ways of doing that. So we're going to start with wash method, which is where we left off. And there are 4 different wash methods referred to as method A, method B, method C, and method D. And I'm going to pull these up in a little bit more detail here. So method A is our water washable penetrants. And these are the least sensitive, but by no means are they not sensitive. So these you can get up to, we'll talk about sensitivity level. We talked about there's half, 1, 2, 3, and 4. So these can go up to level 2, which is what you typically are going to use for most aerospace applications. There are some supercritical components where you may need to go to a level 3 or a level 4, and for those you need to use methods B or D. But for water wash, for 99.9% of the things we're going to do, water wash is an acceptable method, is sensitive enough. And the advantage of that is it's very reliable, easy to do. It's pretty forgiving in terms of the process and what kind of skill the inspector has to have in order to use it. It's pretty fast, minus the one big disadvantage time-wise with liquid penetrant is those dwell times I was talking, where we have to let the penetrant, we have to let that capillary action pull the penetrant into the various cracks and crevices. And so here we are, again, most methods, but if you need extremely tight, small cracks, you may have to go with something that is a B or a D method, or a B or a D method in order to get those smaller cracks. So I'm going to skip to method C because this is the other one we're going to do, and this is the other one that's common in industry. So method C is more sensitive than method A. It can be the same sensitivity, but you can get it slightly higher. It's still less sensitive than methods B or D. So on that scale I was talking about of half, 1, 2, 3, or 4, a solvent removable, the cap on that is a level 3. And so that's where it's a little bit less sensitive than B and D, which can achieve that level 4. In this case, because we're using a solvent and our penetrant is oil-based, we have to be careful that we don't overclean the part, because the solvent that is the solvent we use to remove the excess penetrant also can have the effect of dissolving the penetrant out of the cracks and crevices. And so it's highly aggressive, so we have to be kind of careful and pay attention to how we're doing it. So it's a little bit more process dependent than your method A water washable, which is going to be the most forgiving. Okay. This, however, is probably the most common method we use simply because it is portable. It's able to be done in a portable and aerosol setting. And so for in-service inspections on parts that are either installed on aircraft or if you're outside of aviation, items that are installed in in a production line or on a pipeline or any other application like that, it lends itself to those kind of applications versus something like the water washable or methods B and D, the lipo or the emulsifiables, post emulsifiables. those have to be done in on like a fixed bench kind of environment. But you need more equipment, you need a location to do them. And so method C, again, most common we're going to use because we can use it for on-wing inspections. We can use it for in situ inspections and those kind of things. B and D I'm going to put together because they're known as post-emulsifiable methods. Okay? And so what this means is hopefully everybody's familiar with the fact that oil and water don't mix. And under normal circumstances, water does not wash away oil. Right? Now, our method A, water washable, that has an emulsifier actually in the penetrant. And most of you, hopefully all of you, are familiar with a pretty common emulsifier in your everyday life, and it's one you use in your kitchen, hopefully, when you wash your dishes, and that is dish soap as an emulsifier. So I see people shaking their head. I'm not surprised at who I'm seeing shaking their head. So you're the roommate that has the giant stack of dishes and all your other roommates have to clean up after you, scrape the crusty food off. Yeah, I had one of those. So anyways, is used to dissolve like food grease and that kind of thing and allows water to wash that away. That's the same thing that's happening here with these method B and D penetrants is after the penetrant is applied, we have to use an emulsifier to allow the water to remove it. A method A, that water washable, that emulsifier is actually in the penetrant already, is the way that works. So that's why these are called post-emulsifiables. You put the emulsifier on after the dwell time. And so you have that initial emulsifying step. And these are the penetrants that can reach that level 4. That's that extremely high sensitivity level. And so that emulsifier allows for that breakdown and wash away of the excess penetrant. At the same time, it's very, very process dependent. If you leave that emulsifier on too long, it will work its way into those same cracks and crevices you're trying to find, and it will wash away the dye that you want to stay there so that you can find those flaws. And so it's easy to overclean. So method B is what's called lipophilic. So when you're dealing with these oils, the root word or the root syllable for oils is lipo, right? Or many of you have probably heard of like lipids if you've taken biology or other classes like that. So fats and oils. So lipophilic, method B, is more strongly attracted to, and philic means attracted to. So lipophilic is more strongly attracted to the oil molecules in the penetrant. But it's a polar molecule, so at one end attracts to the oil, the other end attracts to water, but it's more attracted to the oils. Method D is hydrophilic post-emulsifiable, and that one is more tightly bonds to the water molecules. And it's the hydrophilic, hydro being water, philic being affinity for or bonding to. So method D bonds more tightly. So method B, because it wants to get into that dye so bad, because it wants to meet up with that oil so bad, it is extremely sensitive, and it is much, much, much more likely that you'll overwash something when using method B. Method D, because it's more closely bonded or more tightly bonded to the water, is a little bit more forgiving. And so because of that, method D has basically replaced method B for those ultra high sensitivity inspections, because it is more forgiving in that. So the difference there is with method B, a difference of as little as 15 seconds during wash time can make the difference whether you see flaws or not. So if you wash it for 15 seconds longer than you should, or if the method B emulsifier is applied for 15 seconds more than it should, it basically will wash out the dye you're looking for. Whereas the method D, the hydrophilic, that has more, that forgiveness is up to more of about a minute. So you have about a minute of play on how long it's on the part or how long you wash the part before you get into that overwash territory. So the next item we need to look at is the developer. So we looked at the penetrants, we looked at their levels, right? 4 different levels. Sorry, 5 different levels, 1/2, 1, 2, 3, and 4. And then we looked at our methods, A, B, C, and D. Now, the next classification has to deal with our developers. And so developer is what draws the penetrant out of the flaw. This is where that blotting action comes in, right? So a few of the vocab terms we talked about, you know, the dye is applied to the part. We want it to fully wet the surface. You know, we want it to flow over the surface and wet the surface, and then we want that capillary action to pull it down into the cracks. We rinse off the excess, and then we apply a developer, and that's almost like taking a paper towel and blotting against the part to pull that dye back out of the cracks so that we can see it when we perform our inspection. And it's another name for it is wicking. You can call it blotting or wicking. And so it pulls it out of the crack and it brings it up to the surface. The other part is it with fluorescent as well as visual helps to spread it out. So remember, we can't see these cracks because they're super narrow. So when it pulls the dye up, it doesn't just pull it straight up, it pulls it up and kind of flares it out a little bit. So we get a little bit wider, shows the crack wider than it actually is. And that way it's wide enough that we can see it better. Our visual acuity allows us to pick it up. Right? So it spreads it out. The other thing that it does is many forms of developer, not all, but some, many, leave behind, they turn essentially the surface of the part typically white. They leave like a chalky residue on the surface. So that chalky residue is what performs the blotting action, first of all. But second of all, by creating a white background, if we're using a fluorescent penetrant, when we shine a black light on it, or a UV light on it, it makes that penetrant, that bright green yellow, show up against a white background really well. Or if we're using a visible dye, like a bright red visible dye, that'll give you that bright red indication on a fairly consistent white background. And so it makes it easier to see. Okay. And so with this, with most developers, we're looking at about minimum 10 minutes that we need to put it on, allow it to sit and blot that, blot or wick that dye back out of the flaws. Minimum of 10. Sometimes it needs to go a little bit longer, right? Sometimes it takes a little bit longer to bring that dye back up to the surface. There really isn't a concern from an inspection standpoint of leaving it on too long, right? It just means it's going to pull that much more dye to the surface. There is a concern with leaving it on too long, though, is that you don't want it to like dry and harden. And I'm talking about leaving it on for hours or days after your inspection. So it's important that after the inspection's done, you clean this stuff off so that it doesn't leave a residue on the part. And in addition to that, some of it does get pulled, it does kind of work its way into the cracks. If it dries in the cracks, it can actually clog a crack. And then the next time somebody inspects the part, the crack gets smaller. And you have the same concern with dye. So dye or developer getting into those flaws, right? Especially if it's a flaw you're monitoring over time where there's a certain amount of allowed damage and you're making sure it's not growing too fast or that it hasn't grown too large. It's really suspicious when you measure a crack today that's 1.5 inches long, and then you come back a month from now and that crack is 3/4 of an inch long, right? Most of the time this is metal. Metal doesn't fix itself once it cracks. There's a few materials out there that are self-repairing. Metals are not one of them. Unless you're like, what, the T2000 Terminator? What's the one that was all mercury like, right? Shot him with a shotgun and you just like back in. Huh? How many people have seen Terminator 2? I hope most of it. Really? That's it? Oh boy. The T1000, yeah. Sorry, T1000. We only have like 6 people that have seen Terminator 2. Okay. We gotta have movie day one of these days. That was the first movie that absolutely scared the daylights out. I was like 8 years old when I watched it. I'm like, great, the world's gonna end. I'm gonna die. The whole beginning, nuclear explosion, people being burned into skeletons. I'm like, yep, I had nightmares about that for weeks. Thank you, Uncle Tim. So developer comes in 6 forms: form A, B, C, D, E, and F. And yes, you do need to remember which one's which. So form A, dry powder. B is water soluble. C, water suspendable. D and E, I kind of combine. They're both non-aqueous, and they have to deal with what type of dye you're using. And then form F is the special one. So form F actually can be more than one. It's just everything that doesn't fit nicely in these other 5 categories. And actually, there used to only be 5. Form D and E weren't split until maybe 10 years ago. They used to just be called Form D. So first one, Form A, dry powder. This is a dust. It can be used with all type 1 methods. So what are type 1? Type 1. What's type 1? Huh? Ultraviolet, right? It's your glowing dye. What's type 2? Red visible, right? Usually it's red. I've never seen anything but red, but I guess there could be another color out there, but visible dye. Okay. So dry powder, this is the least user friendly, mainly because it makes a dusty mess. It is a very, very, very fine dust. It's really easy for it to go everywhere if you sneeze into the bucket or move it around too quickly. Okay, or if you drop it. We had a student drop the bucket of it on the floor one time. That was fun to clean up. You can't use like a regular vacuum. You have to have one with a special filter on. If you use a regular vacuum, it will pull in all that dust, and then it will just send it out the outlet into the room. Ask me how I know. So least user-friendly. It's hard to completely and evenly dust the part also. You have to get that dust to basically touch every surface of the part. And the dust itself, what you see, what you're able to see, is just a carrier powder. Almost like a talc powder type. It feels almost like talc powder if you touch it. But the part you can see is actually, the particles are not the developer itself. What it is those particles have like a coating developer chemical on them. And as that dust kind of falls or rubs against the surface of the part that you apply it to, it leaves behind that developer coating. Okay? And so that the actual developer coating is only sticks to those areas where the dye is present. So this does not leave that white background like some of the other forms do. Okay, this one pretty much, the part color is the part color. It doesn't really leave a white contrast background. It's easy to handle and store because it's a dry powder. You don't have to really worry about it leaking. It doesn't really, they do put expiration dates on it, but it's pretty stable chemically. And so it's easy to store. Just know that, if you pull the lid off the container too fast, or if you just got to be careful that it doesn't get airborne and go flying everywhere. And it's fairly inexpensive. And so, that's an advantage, particularly if you have like a high volume thing, or if you're working in like a general aviation shop. But that inexpensive part, a lot of other stuff has come down, so it's not as big of an advantage as it used to be. Okay. Our next type is what's called Form B, and this is water soluble. Now, we won't use this one. We don't have this in lab. This can be used, and dry powder, all type 1 methods. So method A, B, C, and D, right? So water soluble, used with all penetrants except method A. Any idea why we can't use water soluble? So water soluble means we dissolve it in water. It's a powder. You get it in a package of like powder, and you dissolve it in warm water. And then it stays dissolved. It turns that water into kind of a solution, and then when you put that water over the part, the water evaporates, leaving behind the developer that was dissolved in it. It's kind of like if you take salt water and it evaporates, it leaves behind salt crystals on whatever that was in, right? Or sugar crystals if you ever made crystals growing up. Or the salt that ends up all over your car in the winter in Michigan and then causes it to rust out. So it leaves that behind, used with all penetrants except method A. Why can't we use it with method A? What was method A penetrant? Water washable. So what do you think happens when you apply water soluble water-based developer on water-soluble dye, water-washable dye. What? They mix and it washes the dye off or washes the dye out. It's like continuing to wash it, right? So we can't use it with a dye that is water soluble, okay? It doesn't, I say here, it does not require drying of the part. It does not require drying of the part before we apply it, okay? It does have to dry after it's applied. All developers do in some way or shape or form, unless, you know, dry powder is already dry. But most of these, right, like Form A developer here, dry powder, if you wash your part with water, you have to dry your part before you put the powder on, or it's just going to clump and stick to it everywhere, right? So this requires that we dry the part. This does not require we dry the part before we apply it. So powder is mixed with water. It creates a solution. That means you don't have to continue to agitate it. Water-based, though, can pose things like bacteria. If it sits around long enough, it can start to grow stuff in it if it gets contaminated, and corrosion problems, moisture on your parts. Form C is water suspendable. So again, this is another powder that we kind of mix in with water. We slosh around with water, but here it doesn't dissolve. It is in a suspension. So it, you know, being in suspension, that means that the particles themselves don't dissolve. They stay little particles. They're just floating around in there. So we have to keep it agitated, otherwise all the particles settle to the bottom, right? We don't want to just be applying the water to our part when we're hoping to apply the developer. So we got to make sure that those particles are floating around in there when we do the application. Again, we don't have to dry the part before applying it. Again, this can't be used with water-based penetrants, with Form A penetrants. Sorry, Method A penetrants. And again, it can cause those bacteria and corrosion things. Here also, water evaporation is a concern. If the water evaporates, that means the concentration goes up, and there's a minimum and a maximum concentration. It's kind of like taking the particle levels for magnetic particle, right? You need a certain amount, but you don't want too much. Forms D and E, I'm going to talk about together. These are your non-aqueous, non-water, not water, solvent-based. Okay? So now, again, now you have a developer of some kind, but instead of being dissolved or suspended in water, now we take that developer, we dissolve it, and these are only dissolved, they're not suspended. We dissolve it in a solvent, and it's typically a solvent that is going to be fast evaporating. And where we most of the time is you take that solvent and you know, if the solvent's left out in air that's fast evaporating, it has a what is it, a low partial pressure, right? Cause it to vaporize. So if it was left out in air, it would just evaporate. So we can't leave it out in air. So typically these non-aqueous solvents are put into an aerosol can, right? So as long as they stay in the aerosol can, it keeps that liquid. They're under pressure. You know, the liquid doesn't evaporate, but then as soon as you spray it from the aerosol can, it coats the part, and then that solvent's able to evaporate, and it leaves behind the developer. And these do leave, again, that white coating. So by the way, the water, the Form D, Form B, Form C, both the water soluble and water suspendable, those typically leave a white coating or some kind of a surface coating. Non-aqueous solvent leaves a surface coating as well to increase contrast. So they can be used with all types and methods of penetrant. And the term, whether they are a Form D or a Form E, is dependent on what type of penetrant you're using them with. So Form D is used with type 1 penetrants. Form E is used with type 2 penetrants. The non-aqueous solvent-based developer you're going to use in aerosol cans is actually a dual form. It's a dual form. It's D and E. It can be used with either type 1 or type 2 penetrants, and in the lab you will use it with type 1 and type 2 penetrants. So when you're using it with a type 1 penetrant, you refer to it as a form D developer. When you use it with a type 2 penetrant, you refer to it as a form E developer. But it's a dual form. We've gotten these, the stuff we got for portable. We have 2 penetrants. We have a fluorescent type 1, and we have a red visible dye type 2. And we specifically got those 2. We spec those 2 up because they actually use the same developer and they use the same cleaning solvent for both of them. So we really only need it if I have 4 cans instead of 6 different cans of stuff. So these are the most sensitive, but they're easy to perform improperly. Okay. Over application can wash the penetrant from the flaws. Over application can also hide flaws because if you get the developer on so thick that the blotting action can't pull the dye or the penetrant all the way up to the surface where it's visible, where we can see it. And so these are applied by spraying. They're applied in a spray can, and the same rules that you use when you've learned to like paint with your air sprayer or with rattle cans applies for these. If I'm applying it to my part, I need to make sure, one, that my can is well shaken up. I need to start spraying to one side of the part, smoothly bring it past, stop spraying on the other side. Right? I don't want to sit here and press the button. That'll leave a big circular blob of material that's way too thick and it'll hide our indications. So you want to do nice passes, even around the whole part, never starting or stopping your pass while pointed at the part. Okay, so it's just like you learned in structures painting class. And again, these are all in aerosol form, so they're part of those portable systems that make it easiest to do in situ or on wing. Form F are these special applications, or special application developers. So they're not any one specific type of developer or one specific chemical makeup. They're everything that doesn't fit in the other categories, in the other forms. And so where you see these are plastic, the most common forms of Form F are what are called plastic or lacquer-based developers. And the idea of those is they almost act like a paint where you spray them on, and then as they dry, they blot the dye out, but then they harden and they leave a permanent indication on whatever it is that you're inspecting. They're not really used in aerospace. They're typically used for things like civil engineering. They'll put them on like a bridge or something like that where they want to be able to see a permanent record of a flaw. And in the case of that, then they're not removable. When I say not removable, they're not removable in the form of they can't just be washed off once it hardens or dries. It has to be removed with like a lacquer remover or a paint remover. So it isn't 100%. There are methods to get rid of it, and that's what would be used again if they're doing like crack monitoring in bridges or other metal structures that are for civil engineering. But it's there so people can see it, so they can kind of go back and keep a record. They've become a lot less important since electronic and digital record keeping systems have come around as well, because now you can use one of the other methods and forms and then clean it off, but then have a record that's easily accessible by the next person through computerized systems, where this used to be the way to make sure that the record didn't get lost when all you had was like one paper copy in a file somewhere in the back of a city inspector's office. So when we're performing NDT and when we are going to provide a report to the customer or to your instructor, here's what you need to include. You need to make sure you include what type of penetrant are we using, 1 or 2. So again, we'll use this as a review. What's a type 1 penetrant? Ultraviolet, fluorescent. What's a type 2? Visible dye, typically red. Okay, sensitivity levels, 1/2, 1, 2, 3, or 4. What's the sensitivity level typically required for commercial transport aircraft? 2. Level 2 is what's required most of the time. Now, when you're looking for particularly small cracks, super critical areas, sometimes engine components, if you're getting into more of the space side of aerospace, that's where you're getting into those level 3 and level 4s. Okay. What sensitivity level does type 2 come in? Type 2 is visible dye. What's the max sensitivity level we can get with type 2? Level 1, right? That's why it's not usable for transport aircraft. It is often acceptable for general aviation aircraft. You can use visible dye on like the Cirrus, for instance. In fact, I believe that's what they use. If I remember right, that's what they use down here in fleet service. Is it they use red dye? Yeah. Yeah. Red dye you can get just about any like industrial supply house or anything like that. Factory, machine maintenance, the technicians I had working with me used red dye, visible dye type 2. Okay, how about methods of wash? A, B, C, and D. What's method A? Water. What's method C? Solvent removal. Who wants to method B and D? Anyone want to? They're post-emulsifiable. And does anyone remember what B is versus D? Lipophilic, is that B or D? That's B. And what's D? Hydrophilic. So post-emulsifiable lipophilic is B. Post-emulsifiable hydrophilic is D. And then finally, we have our forms, our 6 forms of developers. What's form A? What's that? Dry powder. Form B? Water what? Water soluble or dissolved in water. How about form C? Water suspendable. Form D? It's non-aqueous solvent used with what? Used with fluorescent type 1 dye. How about form E? Non-aqueous solvent used with type 2 dye. And then form F? Just all you need to know is special purpose. Call it special purpose. But yeah, most of them are plastic or lacquer based. Okay. So let's look at the process of performing LPI. So I've kind of talked as I've gone through the different materials, but here's our general overview. We want to remember the part has to be clean so that we don't have anything on the surface that could react with our penetrants or our developers for that matter. We need to apply our penetrant and allow it to dwell. We need to remove the penetrant and rinse it. If we're using a post-emulsifiable between applying and removing, we'll have to put our emulsifier on. Then after we've removed it, developer, we apply it, allow it to dwell or allow it to develop. Now, if we're using a dry powder developer, we have to dry it in between so that it doesn't clump all over the surface. And then finally, once it's allowed to develop, then we can do our inspection. When we're done, we probably want to clean it up when we're done. So pre-cleaning to remove any of that oil, grease, gasket material, dirt. Right? When you're doing engine stuff, gasket material is important to get off of those sealing surfaces. You know, it's not an uncommon area to get cracks, particularly if you're doing automotive, right, around like head gaskets and things like that. Okay. By the way, if you are rebuilding a car, visible dye works really well to try to find cooling, coolant leaks and that kind of thing, internal coolant leaks when you're doing head gaskets and stuff. We have to strip the paint though. Cracks in paint can act like cracks in the material, but they're just at the surface. So if we have a crack in the paint, we don't know if it's just in the paint or if it's in the metal or material below. And so we have to remove the paint in the area in order to get an accurate indication of whether the structure is cracked. So using things like water, detergents, you can do chemical cleaning or vapor cleaning as well. Steam, high temperature water. That's what we'd use at in the factory environment. Was we'd use something called a hot seat, which is a high pressure, basically puts out, it's a pressure washer that puts out water at about 200 degrees Fahrenheit. It's used to strip oil and grease without using any kind of chemicals. Used it at the airline too. We'd clean landing gear before we did like landing gear changes and stuff. So they're kind of fun to use. Just don't shoot yourself with it. It's really hot and takes your skin off. Do not use mechanical methods though. If you use mechanical methods, you run the risk of basically peening any cracks or crevices back closed again, which will prevent you from being able to get an indication. That includes things like bead blasting, wire wheel scraping, sanding, etc. Sometimes, depending on the material, it is allowed to use something like a shot blast that has walnut shell in it, or plastic beads, something like that. But metal shot, bead blast, wire wheel, any kind of metal on metal has the risk of peening those holes, those closed. And soft metals like aluminum, even something like walnut shell or plastic can actually peen that surface closed. It's really only if you're using a hard steel you can do that. Okay. When we apply the penetrant, if we're using a liquid bath, we can just dip the part in it. We can also spray it. If we're using like an aerosol-based penetrant, we're going to spray it on. You can brush it on. If it's a small part and trying to spray it on with an aerosol is tough, you can take your penetrant from the aerosol can and spray it into like a cup, one of those disposable paper soup cups or something, and then use a brush or even dip your part in it if you need to. So even though it comes in aerosol, it doesn't mean you have to apply it using aerosol. In fact, our aerosol penetrant that we use, our type 1 aerosol penetrant, and our liquid bath penetrant, they're the same penetrant, just one is in a spray can and one is just in a liquid bath. So, they're multi-method. The dwell time, the amount, we allow after we've applied our penetrant, we have to allow it to get into all those cracks, crevices, deformities. Typically 10 to 30 minutes. The procedure you're following, you're going to have a procedure that's going to tell you how long that needs to be. And it's going to be provided by the manufacturer or other representative, engineering authorized representative for whatever component it is you're working on. Okay. In order to determine that, to be able to determine that on a certified part, you have to have typically some material science background, and then you have to be what's called qualified to a level 3 in that method, in LPI. Okay. To just perform LPI, like in the hangar, you're going to be a level 1. You would be qualified as a level 1. Okay. Near the end of the semester, we'll talk about different qualification levels and that kind of thing. But just know to design or make up or figure out what procedure to use, you have to be a level 3. Do not allow the penetrant to dry it on the part. Like I said, we want it on there long enough to get in the part. We don't want it on so long that it dries and actually clogs the crack, or dries and is not able to be pulled back out of the cracks and crevices, which would prevent us from getting an indication if we had a relevant flaw. We're going to remove our penetrant using our different methods. You know what? I'm going to stop there because I want to go over things. So we'll finish up the process on Thursday.